Well, this video is of the R3 representation. All this R3 means is that it's just the third one that I thought of. But the purpose of this thing is to show you how the different loop lengths occur. And as before, if we have just the spiral, then you can see the whole space that we're dealing with. These are the gene coding loops, and these are the non-coding. And again, the general observation is that gene coding, that is loops that are formed by gene coding transcription events and loops that are formed by non-coding transcription events, are approximately equal in number and very similar in characteristics. And so this is one of the major observations that I've made of the nature of Connectron structure over the years. But let's just play with this a bit. As before, I like these one-shot Connectrons, so I'll show these at first, the blues. And so now we'll turn off the non-coding and go back here. So these are the shorter loops, 0 to 10 kb, and it doesn't look like there are any of them. Whereas, oh no, there are. It's just that the blue is difficult to see. Sorry. So, yes, blue is very difficult to see. You'll probably not be able to see it at all. So this is these are the larger loops now. So these are loops that are 100 kb to a megabase in length, and you can see that they occur in various places. And as with the other representations, we can pick, here's a particularly dense section, and zoom up on it, and you see there's a very complex structure of loops of this length forming in this region here. And again, I'll reposition the structure a bit and zoom back. I mean, the tool is very pleasant to work with. These are the loops that are 1 megabase to 2 megabases in length, and then these are the ones that are very long, 2 to 4 megabases. And so we could do the same sort of thing with the non-coding. Turn on the non-coding, and so you see these are the loops that are in the 2 to 4 megabase range, formed on chromosome 1 of mouse. And these were just the one shots. Now let's look at the primaries and go up here with these, and so you see how the lengths come in on these. These are the intrachromosomal loops. So these loops were formed by transcription events on the same chromosome. And then these are loops that are formed by transcription, could be formed by transcription events where the transcription is occurring on a different chromosome, but the loops are on this chromosome 1. And then intra-secondary, there's secondary are the ones that are turned off by some other connectron. And these are the chromosomal secondary connectrons. And then, as before, there are just a few of these uncontrolled connectrons whose function I've never quite determined. But the purpose of this graphic is to give you control over looking at loop lengths in a systematic fashion. And so if you only want to look at loop lengths of a certain range, you can just turn off these switches and see what the results are. So this is, you know, they're relatively few, or they're short, I should say. Here's the ones that are a bit longer, easier to see. And this is just one type, and then you can play with the different types in the same length range. So this is what this representation does. It's pretty nice. It enables you to look at the connectrons in a different way.